Hello. Okay, so do you want me to go ahead and share my screen now? Yes. All right. Okay. Can you see my screen? Can you hear me okay?
Loud and clear.
Yes, you can see me. You can hear me. All good? Great. Thank you, everybody. So today I'm going to be talking about generative design. The future of BIM is optimization. And I'm going to go ahead and start. All right. All good. Okay. All right. So today we'll be talking about generative design. But first I want to start with a quote from The Economist. They say the world's most valuable resource is no longer oil, but data. And so the question that I have for everybody here and that's on the call is, if your data is more valuable than oil, how are you using it? So we've had building information modeling for a very long time. You have all the data that exists inside of your model. But a lot of us aren't using the data in a very efficient way. And so most of us are either using Revit or ArchiCAD or some kind of building information modeling program. And we're trying to get to what we call building information optimization, starting to do stuff with the data. And so in here we have what I call the data-driven chasm. And what we want to do is we want to try to create this bridge from building information modeling to building information optimization and overcoming the chasm. And so with that, in the advent of Grasshopper and Dynamo, some of these scripting tools have allowed us to cross that chasm and create a bridge to building information optimization. And ultimately, where we're going next is generative design. So let's talk about the difference between passive design and generative design. So passive design, you have a human, or in this case, a bald human, and then one computer and limited options, usually not optimized. And this is the way all of us work today. Most of us work in this kind of environment where we have one person working on one computer and just modeling inside of our program. So with generative design, we have still a bald human plus logic and parameters equaling thousands of solutions, which would be optimized. And so this is with the advent of generative design, we can start actually starting to work in this environment and work in this ecosystem where we haven't had this ability before. So if we look at the definition from Autodesk and what generative design is, it's a noun. They communicate as a collaborative design process between humans and computers. During this process, the designer defines the design parameters and the computer produces design studies or alternatives, evaluates them against quantifiable goals set by the designer, improves the studies by using results from previous ones and feedback from the designer, and ranks the results based on how well they achieved the designer's original goals. And so this is a definition directly from Autodesk. And as many of you know, in 2021, they've launched their new generative design tool for Revit. So let's talk about the generative design process. What does this process look like? Because it is very different than traditional processes. If we're using new tools, new technologies, there's disruptions that happen and the process changes. So typically we look at generating various design studies using generative design. We explore those different generative designs. We analyze and interrogate them. And then we can really go one of two directions. We can either start to evolve those design options. We can start to rank them. We can rank them and then send them back to be changed or evolved, and then analyze them again and rank them. And then eventually what we want to do is then start to integrate them into our design. So this is the process that we use as it relates to generative design. So next I want to ask, how do you design a pizza? So this is my family. This is my wife and our three boys. And we go to a pizza place in Colorado called Mod Pizza. And the thing about Mod Pizza is that you can design your own pizza. So you can see my pizza here has the meat and the veggies. My wife has her gluten-free, dairy-free pizza. Our boys get their pepperoni pizzas and everyone's happy. So our pizzas are customized for each of us based on our own needs and desires. And so what I wanted to do is to actually look at generatively designing how that process would work using a pizza. So here I'm using Refinery, which has now become the 2021 generative design tool. And in here I can optimize my pizza based on pizza size, number of pizzas, does it have pepperoni, does it not have pepperoni? And we can go through this kind of generative design process for a pizza. But the question is can we apply this to a building? And what are the different processes for optimization? So really there's quite a few different ways that you can do it, but the two that are more mainstream is Galapagos for Grasshopper and Revit 2021 Generative Design for Revit. And so Grasshopper has what we call single objective optimization. You're trying to solve a problem using their algorithm to optimize for one objective. Using a parallel graph chart, we can actually do multi-objective optimization, solving for multiple solutions, trying to find solutions for multiple problems. And so these are two different approaches and two different ways to solve. Doesn't necessarily mean one is better than the other, but these are two that you can utilize today as it relates to both Grasshopper as well as Dynamo. Okay, so what I'd like to do now is go a little bit away from kind of academic studies to kind of more case studies that we've actually used generative design on, because I think that if you actually look at real projects, this is where we can start to really leverage some of these tools and validate how they get used in practice. So this is one that we did for our project in Dubai. It was a master planning example. And using the single objective optimization, we were trying to optimize various buildings, retail, office, and storage on podiums, and being able to optimize them based on their programmatic requirements. Another one we did is a generative design tool that we built inside of Revit. And so this is using a packing algorithm. In here you can set the percentages of 1 bedrooms, 2 bedrooms, 3 bedrooms, and set the floor plate. And the computer will run through a iterative process of dropping in different room typologies onto that floor plate. And basically what we wanted to start looking at is if we have, bubble diagrams, departmental adjacencies, data, and a packing algorithm, taking all of these different technologies and tools synergistically together to create a building information model. And so there's various information and various tools that go into this kind of study, but the idea is allowing the computer to generatively design the project, but then the human being able to override whatever parameters that exist in that project. And so the point that I'm trying to make here is that the two are not mutually exclusive. You can actually do both generative design as well as passive design, being able to go through this process in what we call a co-design process. Another one that we worked on was an optimization for view orientation. And using a parallel graph chart, we could go ahead and start to look at view ratios, optimizing different designs based on the view ratio. So in this project, we're trying to optimize orientation of units to views and maximize that. So some of the fixed constraints were lot size, lot location, the view target size, and the view target location. But then the variables were the floor plate location, floor plate ratio, and the view ratio. And so what we were able to do is create, hundreds of options and being able to interrogate multiple options to figure out which option was optimal for the said project. Another one that we wanted to do a case study on was the Autodesk Mars office. And so this is one that you might have seen at Autodesk University a few years back, that they had leveraged their own generative design tools, their own staff, computer scientists, created their own programs. But they had open source Dynamo script. And so we were able to take that Dynamo script and modify it and bring it into the new 2021 generative design tool to look at different options using this user interface. So in here we have adjacencies, buzz, views to the outside, distraction, work style, and daylighting for an office layout. Next is one that we've been building for a client in England. The client's name is Atlas Group London. And basically, we're looking at generative design for hospital layouts. And so we have different department loads. You would have exam rooms, patient rooms, treatment rooms, pharmacies, etc. And then corridors, egress for those various rooms. And then we have the supporting rooms that support those patient rooms. And what we wanted to do is create a generative design tool that as you have those various blocks, that algorithmically the computer could go through and start to lay out those spaces, but then apply corridor width associated to those spaces. And then taking it another level further, we started looking at branching structures, different hallway layouts, seeing how the different spaces would actually interact based on different algorithmic solutions and different branching diagrams. And then finally, once we have a solution identified, what we can do is start to have all of the units and the equipment that comprise that space populated in the Revit model. So, if there's chairs or patient beds, gases, etc., all of that information is able to be populated in real time in the Revit model as part of the generative design process. And finally, this is their video that they created to kind of showcase the overall project. And so in here, we're trying to get healthcare, to places that don't have it. And this is the user interface for the generative design solution, but also going through procurement and starting to identify RFIDs and G codes to be able to create manufacturing directly on site. And to keep a real-time data bank of all of the building information model. And so this is a project we've been working on with Atlas Group over in London. Another example is for schools. And so in this example, what we were able to do is to look at various programmatic information for schools. And what we want for school design is very important because students have to travel from one classroom to another classroom. And what we want to try to do is minimize the adjacencies distance for a student to have to travel from one class to another. And so using generative design, we could go through and interrogate many different options of a school design, but then optimize the option with the least amount of adjacency distance. And so this is another one that we did on the school side. Some of the fixed inputs were the wall face, and some of the percentages are the variables as it related to this project. This one is a tile optioneering exercise. So one of the points to be made is on this example is that not all projects have to have an optimization, and you don't have to apply generative design to an entire project. So in this example, we're applying generative design to only one face, one wall in a project. And this could be, an accent wall in a bathroom. So that way you could start to look at different randomization of tile patterns and densities. And so in this example, I want to try to stress a lot of people criticize generative design because there's just too many variables. The project's too complex. The point is that you can kind of carve out different case studies in different parts of the building to apply generative design, even if it is only just one wall or multiple bathroom tile patterns. And so this is another example that we working on interior finishes for tile. This is and again, this one isn't necessarily optimizing anything. But it is, we're able to go through a process, what we call optioneering, the idea of options and engineering and combining the two. So we can go through and interrogate multiple options without necessarily having to optimize the project. Next is a case study we did for Huff Design. They're in Kansas City in the United States. And this was for Hobbs Trail. It's these camping structures. And a lot of times I get the question asked is, does generative design have to be applied to really large projects? In this example, this is a very small project and it's just this little camping structure. But what we wanted to do is to rationalize these parabolic structures and understand the tube steel length, tube steel count, the angles, the connection brackets, etc., for rationalization of a parabolic structure. And so with this, we used a few different tools. And the other thing I want to mention too is generative design doesn't need to replace traditional processes. In this example, we were brought on for generative design, but we still used many traditional kinds of sketching, for the project. And so these sketches were done by Ben on our team, and was able to actually try to understand how he would start to actually support the structures as they were being built. So we were using both generative design, but also traditional processes like sketching. We started looking at using Grasshopper for some of the form rationalization. Grasshopper in general usually is a better form rationalization tool than Dynamo. So we kind of started with Grasshopper first and wanted to see how far we could kind of take the project just using Grasshopper. We then brought this into a tool called Shapediver, and you're able to actually update the building information model in the web interface. So you can publish your Grasshopper script, and then they have this very beautiful UI where you can go through and modify these parameters. The nice thing about this process is that if you want to start having kind of more client engagement and having clients help with the design and not necessarily, they don't have to be a Grasshopper wizard or know how to use Dynamo. You can just publish these sliders, and then the client can actually modify these sliders. There's no special software needed. All they have to do is just go to the website domain to access this, and it's a great way for clients to be a part of the design process without necessarily being a computational designer. So we kind of took it into this environment. It was pretty successful, but we wanted to flex the muscles a bit in the new generative design tools in Revit. So we started to bring the project into Dynamo, starting to look at the forms, the divisions, seeing how the tube still would actually interact with the edges, starting to get the tube count, things like that. And then finally, we brought it into the Revit 2021 generative design tools. And then in here, we could actually start to interrogate some of the model optionalities using scatterplot map, as well as a parallel graph chart for the generative design process. And then here, this is one we built from scratch for Mortensen construction. A lot of times people think that generative design is more of an architecture exercise, but I actually think there's many opportunities on the engineering side because there's more math, and the math can help drive the design as part of this process. So this is one that we did for Mortensen construction for solar. And so we were able to calculate AC wattages, acres per watt, their GCR and DC wattages, and then generate multiple different options, and then be able to pick from those options based on the engineering calculations that comprise them. This one was for Millennium Airport. And this project was very interesting because we had this kind of parabolic structure for this curtain wall. And what we wanted to do was to minimize the amount of custom panels. As you know, if we can have all the same size panels using a unitized connection, it's very repeatable. It's a cheap way for construction. But if you have any kind of custom panels, which are these red ones up here, these are more cost prohibitive. So what we wanted to do was to use our parallel graph chart and our generative design to minimize the number of custom panels. And this exercise was able to help us to do this. Okay, and now I want to apologize. I have 2 more slides, but I had a few issues with the video not working, and I think the videos are still very good. So what I'm going to do is actually just exit out of PowerPoint for a second, and I'm going to show these 2 videos here, and hopefully you can see these. But this is the idea of applying generative design to modular construction. So this one here we worked on and was able to have multiple different options. We have tube stills, we have angles, we have connection brackets, and we have different units, 1 bedrooms, 2 bedrooms, 3 bedrooms. And so as we go through a generative design process for the building, we can superimpose the modular components, the kit of parts, all the tube steel, the angles, etc., associated to those units in relationship to the building. And so that was a process where it's combining multiple technologies, generative design, as well as modular construction for this project. And so this is a very good application for this, especially for very kind of repeatable projects like multifamily, storage units, etc. Okay. Next is an optimization that we did for an ACM metal panel manufacturer. Oh, this works great. And so in here, what we're able to do is apply ACM metal panels to the building. So you have multiple building typologies, and what it's able to do is actually apply the ACM metal panel to that building using generative design and rationalizing the building. So no matter the size, how many floors, tall, big floor plate, etc., it's able to apply those panels to the building. And then we go through a rationalization exercise, extracting all the data from the building information model, being able to create a bill of materials, quantities, as well as rationalizing in real time bend tolerances. And so in here, this will actually get sent to the shop for fabrication. And in real time, we're able to rationalize, flatten the project using generative design, but also using some algorithmic techniques. And so the point on these two projects is this is not, just architecture. This is manufacturing. So, we have both construction, modular construction, or what I'm calling computational construction, as well as generative design applied for manufacturers. So architects are not the only ones that benefit from some of these technologies. Lastly, what I want to communicate in conclusion, we've talked a lot about different technologies, Grasshopper, Rhino, Revit, Dynamo, different projects, that we've used generative design on. But I want to talk about, what it means for you. So in here, the big takeaways is if you're an employer, what are some things that you can actively do? One is invest in your people. Find the best talent in the industry and hire them. Hire people that are smarter than you. We do this all the time at Evolve Lab, where we want to hire people. I am definitely not the smartest person on our team. People on our team are much smarter than I am. And so we try to hire people much smarter than we are. We invest in research and development and encourage other people to do the same. If you're an employee, if you're coming in or you're a contractor, invest in yourself. There's plenty of resources on websites like blogs or LinkedIn Learning, lynda.com, etc. Learn to code, even if it's only visual programming. So visual programming is kind of the gateway drug, I call, where you're able to visually see what's going on. And it's a great way to kind of step into some of these tools. Learn how to work with digital fabrication and robotics, as well as data-driven design. Become the expert at your company and bring information back to your firm. So after this conference, bring this information, bring these slides back to your firm, talk to your superiors, but then also don't wait for someone to ask you. Don't wait for someone to say, hey, can we try generative design on this project, and are you willing to do it? Take the torch, take the initiative, and learn how to do it yourself. And so those are the big takeaways and action items I would encourage everyone on the call to do. With that, I want to thank you very much. I want to thank the whole team for running all of the technical execution on the projects, getting the video calls, and everyone that joined in on the call. We thank you very much. If you need to get a hold of me or myself, you can find me at bill@evolvelab.io or our website at evolvelab.io.